Nafisa?
No, I do economics.
Oh, okay. Okay. So yeah, it's a pity the following week we were wanting to do a study skills workshop. So you guys saw that poll we did. So next week Saturday we're
Yeah.
going to do a study skills. I'm going to do the workshop. Okay. So let's look at the questions. So let's start with Amaro's one, but Amaro's not here. Okay, let me. Nafisa, you want to do your one first?
Yeah, we can do my one first.
Let's just get the. Okay. No. Okay. So Amaro, do you want to maybe just explain how you approach this question? Like how did you read the question when you read it? Let me just make it bigger. So I want you, like as if you are reading the question now. I want you to read it because it's very important. And I hope you guys have noticed this, that for me, you extract so much information from the question before you see the actual question. From like from this statement here, there's so much information. So I want to see when you guys read the question, the statement, what you guys pick out. Okay, so Nafisa, do you want to try?
So the PQR triangle is the horizontal plane, and then
Yes.
they say
So what?
that SR,
Yeah, and SR is a.
SR is the vertical tower, so it will make a 90 degrees by that SQ
So
angle thing.
SQ is a vertical tower. They should rather say SQ, don't you think?
Mm.
They should say X. Okay. So when you see horizontal and vertical, what do you think of?
90 degrees
90 degrees.
And
and trig,
what did I tell you about 90-degree triangles?
trig ratios.
Good. Okay, so you guys are getting the hang of it now. Okay, okay. Carry on.
And then they say the angle of elevation from S is theta.
Mm,
And
yeah, so
then
they show this in the diagram. Yeah.
say SQR, angle Q is equal to angle R, which is equal to theta.
Yeah, so they give you two thetas. Do you guys see? Here's the one, and here's the other one. Do you guys see that?
Mm-hmm.
Okay, and then they said PQ. Okay, what else did they say?
And then angle PQR is 30 degrees and PQ is 6 meters.
So when they say PQR is 30, like does that sort of, it's like for me when I read that, I think to myself, okay, this is definitely going to be simplification because 30 is a special angle, right?
Mm-hmm.
What are the special angles that you guys know?
Sine 30, cos 45, and
Oh, well,
then
it's just 30, 45, 60, and
60.
60, 90.
yeah. So whenever you see these numbers, like always think to yourself, like, okay, maybe I probably gonna have to simplify this stuff. You guys see that? Okay.
Mm-hmm.
So now it says express QPR in terms of theta. What did you understand by that question?
Like we must have an answer in terms of theta. So theta must be in the answer.
Yes. So what are you solving for?
You're not solving, you're just expressing, I think.
Yeah,
The angle P, yeah.
you're expressing P. Yeah. So you're gonna say QPR equals something with theta in it. That's what I'm saying.
Mm.
Mm-hmm.
Okay. So how did you? What was your approach for that one?
Angles in a triangle, which is 180, and then they give you 30 degrees, and then they give you theta. So the other angle has to equal to 150 minus theta.
Yeah. So 30 plus theta plus this equals 180. So therefore, if you solve for this, it becomes 150 minus theta. Okay, that's not too bad. Okay. And then it says the next one.
Express QR in terms of h, and we must use trig ratios, I think, because it's the vertical plane.
So yeah, so what did you do? How did yeah,
Oh, I
so
think
which triangle did you make use of? The horizontal or the one on top?
The one on top, the
Okay.
vertical one.
Mm, okay,
Mm,
so what did you
so,
do?
um, what did I do?
Elias,
Yes.
don't we use trig functions for this?
Yes, yeah, that's why it says there. Yeah. So
Oh,
Nafisa is saying she's going to use this triangle, but so they want QR, right? So how are you going to find an expression for QR?
Oh, they tell you that SQ is H, and then they give you the angle R, which is theta.
And
So,
yes.
and they want QR, which is next to the angle, so it's adjacent and opposite. So it's tan. That's why you say tan theta equals angle H over QR. And yeah. Oh, and then you make QR the subject of the formula. So it will be H over tan theta.
Yes. Correct. Well
mm.
done. Which is there, but which is good. Okay, so I'm glad that you guys are. Do you guys see that you are adding to your knowledge base now, Navisa?
Yep.
You see, because you saw it's a 90-degree triangle, so now you're thinking trig ratios. Okay. Hence, okay, this is the one that you wanted, Albert. Hence, show that h equals that. So what did you think when you saw that?
We must work out stuff by the horizontal plane and then go to the vertical plane, I think. But I couldn't do it.
Yeah. So yes. So do you
Because we
agree?
don't have any measurements by the S or Q, and we have information by the Q or P. So we can use one of the sine, cos, tan rule and then work out. I think we can work out Q R, and then we can go back
You,
to
you've
the.
got you've got you've got QR already. H over 10. But they want you to solve for h, right? So and what do you know about h? So we know that QR is equal to h over 10 theta, right?
Mm,
So therefore h is just equal to QR
over
times 10.
10 theta. Okay.
Do you agree?
Mm-hmm.
Okay. But now we have to find another expression for QR. Do you agree?
Yeah. So we use the bottom triangle.
Yes. Yes. So how can you find another expression for QR?
We use 30 degrees and then the 6 meters
Hmm.
and QR. Then we use the cos rule.
You want to use cos rule. So why would you want to why will cos rule help you in this situation?
Because 30 degrees is an included angle between QR and QP.
Yes, but then you
So
would need to you got to work out RP
why?
if because if you use cos rule,
Oh,
then
yes, yes.
you're going to say this squared is equal to that squared plus the squared minus 2b. You get what I'm saying?
Mm-hmm.
All right. So because you don't have this side, I'm thinking to myself, maybe not sine rule.
So,
Oh, no, not cos rule. Maybe
cos
not cos
rule.
rule.
We can use the sine rule.
Do you see why I'm saying sine rule? Because you have multiple angles and you have one side, right? So if you used sine rule to work out QR, right? Remember you want to work out QR. That's the objective, right?
Yeah.
So what's QR? If you use sine rule to work out QR, it's
It
gonna be
will
what?
be sine P over QR.
It's not a nice color. Sine P. P, which is what? You said P is what?
150 minus theta.
150 minus theta.
Okay, 150 minus theta over QR. Can we, yeah, okay, it's fine. Don't worry
But
about that.
I have a question.
Yeah.
I was told that when we want to look for the side, you should put the side first. QR over sine
It works
the
both.
length. Oh,
So
okay.
it
Sorry.
works both ways, because if you have your sine, then if you just multiply out, then you can swap it
Oh,
over. Do you see? But
yes.
it doesn't really matter. Yeah, because I mean, if you write there a over sine a equals b over sine b, can't you multiply by the b? Then
Yeah.
they swap over. Okay. So where are we now, Nafisa? What are you gonna say?
Then we
Sine.
can say and sine wait, um something over 6 meters. Oh, that angle odd, but we don't have measurements for that.
You do? They tell you what angle it is.
No, that's 30. Huh?
Won't you say sine theta over 6?
Yes. So Nafisa, do you see this is angle theta?
I see, but we don't have a measurement for theta.
You
So I
well,
was wondering, can't we work out P or then we have number and then 30 degrees?
but you see in the question it says find a QR well, show that H equals something, but it has theta in the answer.
Oh, okay. Oh, okay, okay.
You see, so it's okay if you have theta in the expression,
Okay.
because the problem is PR, you don't have PR. So it's gonna take too much, it's gonna be extra work if you gotta work out PR. So as I think Mishka said, it's sine theta over 6. Do you agree?
Yep.
Right. All right. Let's see it. Let's actually make this smaller now. Can we simplify that? Let's solve for QR. What are we going to do to solve for QR?
We can substitute QR and write H over tan theta.
So I don't think that is going to,
Help us.
it's no, because you don't want H in the answer.
But then you
You
can
don't
make
want,
H the subject of the formula.
but you already have
Also.
H there, you see.
Oh, okay.
So I'm thinking you have to find another expression for QR that doesn't have this H over tan. You see.
Yeah.
So can't you multiply out by QR?
Yeah.
And then
Yes.
and so it becomes if we multiply by the 6, it becomes 6 there, right? 6, and that goes away, right? And then the QR can multiply over there, and then you divide by the sine theta. Do you agree?
Yep.
So you're left with 6 sine 150. So what can you do to the sine 150 minus theta?
You can make it sine theta. No, never mind.
How can we simplify sine 150 minus theta?
What are we trying to get?
You see, this looks problematic. I don't like this. There's nothing like that there. So I'm gonna try. Why don't we use a compound angle?
Oh, we can.
Okay. But do you see why I don't want to use this? I don't want to keep this because there's nothing like that here. You see? So let's try that. So what is sine 150 minus theta in compound angles?
Sine 150 cos theta minus
Cos 150 sine theta.
minus cos. Now we have to simplify this further. What do you guys know about reduction? What is sine 150? Who's going to do that for me? What did we say? What are the three rules, Naima? Do you remember the three rules?
I think the first one is quadrants.
Yes.
Then you must check the sign.
Right. And then the third one?
I forgot. Oh no, cause I mean that one,
180
this
over
90 and 270.
Okay. So, and if you guys are
So
unsure,
you
yeah.
oh
Yeah.
no,
So
you
Nafisa,
go.
do you want to try this one? Sine 150?
Yeah, it gives you 180 minus 150. It gives you sine 30, and then you can use that because it's a special angle.
I think it's a half. Yeah.
Okay, wait. So do you agree sine 150 is 180 minus 30? You just get that right.
Yeah,
And sine 180
Mhm.
minus theta is just sine of
30.
theta. So it's sine 30, which you
Which is a
guys
half.
told.
And is-
Yeah.
Yeah.
See, do you guys see the special angle? See, that's why when you read the question, when you see 30 there, I think to myself, okay, maybe there's going to be a special angle somewhere. Cos 150, who's going to do that one? Amaro, do you want to try one cos 150? Oh, Naima, you want to try cos 150?
I'm doing it.
Okay.
It will be negative cos 30.
Okay, but now show me using the steps how you. So which quadrant is it in?
It's in the second quadrant.
So it's cos
180
180
minus.
minus, right? And
Oh,
that's which then positive or negative?
it's negative.
So it's going to
And
be
then it's
minus cos, yeah.
mhm.
But there's a minus there already. So what is it going to be?
Positive.
Positive.
But sorry, it's positive cos 30.
Mm-hmm.
And what is cos 30?
Square root 3 over
It's
2.
root 3 over 2.
Do you start seeing now? Here's the root 3. There's the root 3 there. Okay, we're getting there. We're getting there. Now what can we do now?
Multiply out with the 6.
Okay. So what does that what does that give us? We multiply by. Remember, this is divided by. Remember, this is all divided by sine theta. Do you guys agree? This is all divided by sine theta. Because remember, if you look over there, this is all divided by sine theta. So what is 6 times half?
3.
It's 3.
What's 6 times root 3 over 2?
Root,
3.
I mean 3 root 3.
But can't we take, okay, so yeah, so what do you think we can do next?
Take 3 out as a common factor. Can we?
Yeah, sure. And then it becomes 3 open brackets.
Cos
theta
theta
plus
plus
root 3
But
theta.
before we do that, what about the sine theta at the bottom?
we can write it as tan. No. Yes, no.
Don't you want to divide out by all the terms? Don't you think that's a nice idea? Because it's only one thing, so can we divide out by all the terms?
Yep.
Yeah, we could.
So what does that become? What is 3 cos theta over sine theta?
Isn't it 1 over 10?
Yeah, so it's 3 over 10. Do you agree? Because remember,
And
what
that
is
will cancel.
sine over cos is tan, but cos over sine is 1 over tan.
Yeah.
Plus 3 root 3.
Mm-hmm.
Because the signs cancel now. Right. This is QR. What did we say H equals?
H over
H
tan
equals
theta. Right? Oh,
No, H.
QR times tan theta.
So we have to multiply all of this by
Tan theta.
10. Right. So let's multiply it all by 10. So then it becomes 10 and 10.
That
Do you guys
cancels,
agree?
yeah.
This cancels with that. So it becomes 3 plus
Root 3, 3 root 3, 10 theta.
Now you factorize for me, Nafisa.
Take out 3 as a common factor. And then it's 1 plus 3 root 3 tan theta. Wow.
Sure. But my question to you guys is, did we do any fancy maths here?
No.
No.
You see, all we did was we just applied concepts. We applied cosine. Okay, so we started off and we said, okay, Nafisa, you started off fine. You got this, you got that. So we said, okay, let's use, cosine rule, not cosine rule, because we don't have one side. And we don't have this side either. We want to work out this side. So sine rule. And then we got sine rule, but then we had to use compound angles. Do you see? Compound angles. And then we just simplified. Okay, and then we got that. So I don't want you guys to be scared. You see, the thing is, what I've noticed, students often become scared when they see stuff like this. And I mean, to be honest, this does look scary. it does look scary. That's why don't worry about this. Just apply the rules that you know, and you will naturally come to this. That's my philosophy. Don't worry so much about that. Just worry about applying your knowledge. You know, if it's a right angle triangle, what did I say?
Trig ratios.
And if it's not a right angle triangle,
The sine or
rules.
cos rule.
yeah. What else could it be? What else could it be? You see, so you know that's. But do you guys see? There's no set method, but the concepts are the same. That's the point I'm trying to make. Don't go about memorizing methods. Rather, have the concepts strong in your brain so that it doesn't matter which question they give you. You have the concept so that you can derive a method. You see, maths is not about memorizing methods. It's about having the tools to construct your own method. Okay, and we're not done yet. So calculate the area of PQR. What's PQR? Okay. Where's PQR, Nafisa?
Area
Yeah.
The horizontal plane.
So are you going to use half base times height?
No,
Why not?
because it's not a right angle triangle.
There we go. So which one are you going to use?
area rule.
And there's a concept video on area rule. Anybody know the formula?
Half A times B sine C.
Great. See, Nafisa, you're memorizing the formulas here. Okay, you're not reading it on the page.
No, I just remember it.
Okay. It's good.
But
See, I told you
still have
guys.
the formula sheet stuck on my wall, but I
No,
wasn't
but you must memorize. I told you guys, so it's good that you are memorizing. Okay, so half. So what's the two sides that we're gonna use? Which sides do you think would be best?
QR and QP.
Yes, not RP. Why?
We don't have a measurement.
We don't have it.
Yes, so it's gonna be 6 times QR. But QR is this horrible thing here. But they told you that.
Theta is equal to 65 degrees.
So can't you type this into your calculator?
Okay.
So who's going to help you type it into the calculator? And then what's your sine? What's your angle going to be, Nafisa? What's the angle you're going to use?
Oh, 30 degrees.
And what's sine 30?
Half.
Oh,
Half. You see, so they're making it easy for you. So it's going to be times a half. So now all we need is QR.
I got 14 comma 14.
1 4.
Yeah.
1
Okay.
4.
14,14.
So a 6 times a half, which is 3, which is 3 over 3, 1.5. Yeah, 42, okay, 21 point something. What did you get?
21.21.
Okay. Yeah, so do you guys see now? You guys see how we're not doing anything new. It's all stuff in the concept videos that we're just applying, you see. But you can't apply if it's not strong. So that's why we're saying put a big emphasis on those concept videos. Okay. So let's go to Amaro's question. Amaro, you back now? Amaro, is your mic working?
Yeah. Sorry, my connection was, I don't know, weird.
It's okay. It's okay. It happens. I just hope my connection doesn't. I mean, that would be a disaster. Imagine if I lose Wi-Fi. The whole thing. Okay. So, Amaro, do you want to maybe talk to me about how you approach this question?
So I start with the first question, and because they want the inverse of that, I swap in the y's, and I made y formula.
Y the subject of the formula, right? Yeah. So you became x equals log y over half. So therefore,
So it becomes y is equal to a half to the power of x.
And you know how that graph looks? So okay, we don't actually need Desmos for this. There's the concept video on exponential functions that I want you guys to watch. Actually, all the functions, to be honest, to be very honest with you guys, you don't have to know all. You don't have to watch all these videos. The ones that you have to focus on the most: analytical geometry, trigonometry, and functions. You must know those for all the grades. All the grades. I'm not joking. Analytical geometry, especially the grade 10. Guys, okay? So if you look at exponential functions, I teach you guys how to predict. So basically, if I give you an equation, based on your knowledge of the equation, you should be able to tell me how the equation looks before drawing it. So I can tell you now, after the power of x will look something like this. And that's because b is a fraction.
Yes.
Yeah. And a is positive. So if a is positive, it means it's above the x-axis. And if b is a fraction, it means that the function is going closer and closer to the x-axis as you go from right to left. So that's, I mentioned that in the concept video. So the concept video is very important when it comes to, do you guys see that? You see?
Yeah.
There's after the power of x. Okay, so even before drawing it, even before plotting it, okay. Right, so therefore that's, actually no, Amaro, they wanted G. They didn't want F.
They want the inverse of, G.
So it's not, do you see?
Oh,
it's not,
yeah.
Because how would you find the inverse of G? What type of graph is G?
Parabola.
Parabola.
Okay. So it looks kind of like this, right? So how's the graph of the inverse gonna
The
look?
inverse would be like a C.
Like a C, right? It's obviously not.
Yeah.
Okay. So okay, but yeah, okay, but rather plotted properly. Okay. So but how would you find the equation, Amaro?
So first we swap the x and the y.
So then, yeah, what does it become? X equals
Of y squared.
and then
You can divide both sides by half.
what's another way of dividing by half?
Multiplying by 2.
Yeah, so dividing by half is the same as
Yes.
multiplying by 2. You guys see that? Okay. Doesn't really matter, I mean, as long as you do it properly. So it's going to become y squared equals 2x. Therefore,
Y is equal to root of 2.
But it's plus minus.
Yeah.
is this a function?
No.
How can you graphically prove that this is not a function?
Horizontal line.
The
The
vertical line.
Yes, the vertical line test, okay, because it cuts the graph twice. Good. So therefore, we don't call this a function. We call this a relation. Have you guys heard of that in school?
Yeah.
Relationship. Yeah. I remember when I was in grade 10, my teacher tried to teach us functions by talking about actual relationships. Because it just was a disaster. I was just like, just teach it to us properly. Like, just teach it properly. Like, just say it what it is, you know.
But
Okay,
I think because, like, I mean, it would
grade
be easier
10s.
for you guys to understand that way.
No, yeah. Just the way she said it in the moment is just, it's like, yeah. Anyway, did they teach it to you like that in school?
No, they didn't.
Okay. Okay. So what's okay? So that's the equation, right? So what 6.2, Amaro? It says sketch.
Yeah.
How do you think you can sketch this? Do you have an idea of how to sketch it?
So firstly we can okay. So how I tried is okay. So I got plus minus square root of 2x. So I put it in my calculator and found points because that's how my teacher told me to do.
Yes, that's a perfectly fine way you can plot. I mean, so now, I don't know why it's doing this. Naima sort of made another suggestion that you could also just picture the graph, like you don't have to get so before you plot it, you have an idea for how it should look. That's what I'm saying. Do you agree?
Yeah.
Like you know it should look like a C. Okay, but obviously when you plot it, if you want to be super accurate, you can just sub in different points, right? But you already know how it should look, if I'm making sense. Do you agree?
Yeah.
Like for the graph of y equals a half to the power of x, I knew it looks something like this. But if you want to be accurate, you can obviously sub in different points, right? Okay. Anyway, so now you have to plot it. So we can use Desmos. Have you been using Desmos,
Yes.
Amaro? It's a good app, eh?
It is.
Okay. 2 is the numbers here. 2x. Do you see that's like half a C? And then you have to have another one. Y equals minus square root 2x. There's the C. Do you guys see the C?
Yeah.
Okay. And then the other one is y equals a half x squared. Do you guys see that's G, but then the blue and the green is the inverse.
Mm.
You guys see that?
Yeah.
Okay. So we've plotted both graphs now. And how would you show the intercepts of the graph? What can you do?
Y is equal to 0 for the x-intercept, and x is equal to 0 for the y-intercept.
Yeah. So the nice thing is with the parabola, the x and the y-intercept is both the origin. Do you guys see that?
Mm.
So therefore,
Yes.
because both the x-intercept and the y-intercept are the origin, then the origin is also going to be the x and the y-intercept for the inverse because they swap. Okay.
Yes.
And since there's obviously no other y-intercept and there's no other x-intercept, so, and then they say show any intercepts and one other point on each graph. So you guys, that's easy, right? You sub in 5 and you get a y value. Okay, you guys fine with that?
Oh, okay.
Yeah.
Now, okay, what do you think about this one, Amaro? 2 to the power of x, 6.3. When you read the question, what is it? So this is describe the transformation from f. Okay, that's a.
So you look at the equation of f, and then you look at the equation of x, and then you see what's the difference. And
Yeah.
I
So
think it was reflected about the line y is equal to x.
so if you reflected this graph along y equals x, what does that give you? Which function? What's the type? What's the graph that it gives you?
Exponential.
Yes, because the inverse of a log graph is exponential. But what's the equation?
Y is equal to a half to the power of x.
Okay. So do you see that? That's not this.
Oh, yes.
It's
Yes.
nearly there. It's nearly there. You see something very quickly. Yeah. What's another way of writing a half?
2 to the
to the
power
power
of
of
negative.
Hmm.
Oh, it was reflected again.
What's the difference
About
between 2 to the x and 2 to the minus x?
It's reflected in the y-axis.
Ah.
yes.
Ah.
Yep.
So therefore, if you were to describe the transformation, what is it going to be? You first?
First
You
reflected
just
about the line y is equal to x, and then reflected about the y-axis.
Do you guys see that,
Yeah.
Amara?
Yeah.
So do you see how cool this is?
That's actually interesting. I did not do any of the questions that was like this. Like where you first reflected and then you reflected again.
But you understand it now. Like if you've
Yeah.
got log a half x, that's just the inverse of a half to the power of x. But a half to the power of x is just y equals 2 to the minus x. So if you compare the graphs y equals 2 to the minus x and y equals 2 to the power of x, the only difference is that the x's are now negatives. But when you take any graph and you just make the x's negative, you're flipping it about the y-axis. You guys see that?
Yeah.
Okay. For me, the giveaway is the 2 because you have a half and you've got 2. So there's something going on there. There's something going on there. Okay. The domain of f. So let me plot the graph y equals 2 to the x just so you guys can see, just so it's easier to see. Y equals 2 to the power of x. Do you guys see how the black
Yeah.
is the red just flipped over the. You guys see that? The black is just the red flipped over the y-axis. You guys see that?
Yes.
Okay. The domain of f minus 1. Anaima, I want you to try this one. What do you guys remember? What's
Okay, so
that
I
rule that
think
I said? What's that rule that I always told you guys?
what wrong?
With domain and the inverse in the quiz, it's in the quiz.
Oh, you just swap it.
Okay,
So
okay.
so it will be y instead of x. You look at the y values instead of x for the inverse.
Yeah, okay, but when I talk about domain, okay, so what do you mean by that?
Oh,
How does the what do you guys remember? I said this, guys, a few weeks ago.
Oh,
okay, on the
domain,
quiz.
the
all the
x
Yes,
values.
Amaro said it.
All the x values in the function.
Okay, that's the definition of domain. But what did we say about the domain of the function is the same as?
Oh, it's always x is more than 0.
Yes.
Why did you take long to say yes?
So now I got a message from my friend. She was
Oh,
needs some help.
I thought I was maybe like partly wrong.
So say it again. So the domain of the function is the same as the range of the.
The inverse.
inverse.
Yes.
Yeah. Okay, guys, this is in the quiz, guys. You must do the quiz, okay? Guys, you got a promise?
Yep.
Yeah.
Because I
I'm
want
so
this to be.
sorry. Can you please repeat it?
Okay, so the domain of the so Mishka, do you agree that in the inverse function, the x's and the y swap?
Yeah.
That's the whole point of inverse. So if the domain of a function is, a, and the range is b, then the domain of the inverse is just going to be b, and the range is going to be a because they swap. Does that make sense, Mishka?
Yeah, it does. Thank you.
So they want the domain of the inverse.
So it will be y is greater than 0.
Okay, but they want the domain of the inverse, so therefore I have to find the range of the
Range.
function. So what's the range of the
Yes.
function?
Y
The
is equal
function
to
is
0.
log.
Y is greater than, sorry. No?
The log
Then?
graph. Okay, what's the graph of the log graph? How does the log graph look?
It's that blue one.
No, that's the inverse. Okay, let's plot it.
Parabola.
Let's plot it so you guys can see. So guys, the concept video on the logs, very important, especially the inverse of the straight line graph.
I hate logs.
Yeah, same.
I think it's nice.
See, the concept videos make it nice. Okay. How do I do this now? How do you do that now?
I'm so sorry. I have to go. Will the lessons be will this video be recorded?
Yes, they all recorded. Yeah, they're all on YouTube, so you can go back. Okay, see you,
Okay,
Mishka.
bye.
Okay. Okay. How do I find this? There. Okay. Come on. There we go. x, and it's gonna be 1. No.
Just say 0.5.
Yeah.
Sorry. 0.5.
X.
Right. Let's just remove all this stuff here so it's easy for you to see. What's the range of the? Let's change the color. Okay, let's just remove that rather. What's the range of the log graph? Somebody playing a Call of Duty or something. Do you guys see how the range is going on forever?
Mm-hmm.
Yeah.
There's no asymptotes. Okay, it's only an x asymptote. Okay. Okay, guys, what's the domain of the exponential graph?
X is the element of real.
So what's the range of the isn't the domain of the exponential the same as the range of the log?
So it's so it's y is real.
Y is the element. So therefore, guys, do you guys agree the y is the element of the real?
Mm-hmm.
Mm-hmm.
Okay.
Yes.
So therefore, they want the domain of the inverse, but the inverse is just an exponential graph. What's the domain of exponential graph?
X is the element of real.
Right. Explain why g minus 1 is not a function. We spoke about that, right? Vertical line test. Okay. How would you restrict the domain so that its inverse will also be a function? We did this in the quiz.
You make it greater than the turning point.
Yes. What's the turning point?
0.
So x is greater than or equal to 0, smaller than or equal to 0. Good.
Yep.
So this question wasn't. Yes.
So for 6.5, right? So we did the vertical line test, right? But how do we explain it? Do we just
Oh, you just write that for every x value, there are 2 corresponding y
which is
values.
not definition of a
And
function?
that's
So we
not a
just say
function.
that.
There we go.
Okay, thank you.
Okay. So because remember what's the definition of a function?
For every x value,
There's only one corresponding y value.
Hi, Tabi Singh, how are you? Okay. Okay, so you guys happy with this question?
Yes.
Okay. Let's go on to. Okay, why is she sending all this stuff to me now? Okay. Okay. Okay, so this is a question that Lane asked. Tabi Singh, you don't have any questions today? Oh, she's not here. Okay. So this is a question that I want you guys to think about. Number 2. What do you guys think? Can you hear me?
Yes, we can.
Yeah, we can. So I think we can use the special angles and then break them down, something like that.
Is 75 a special?
No, we break it down into 2 special angles. So it will be like 30 plus 45 gives you 75, and those are special angles.
Yes. Well done. So do you guys agree 75 in itself is not a special angle? But it's composed of 2 special angles. Why?
Because if we add 2 special angles, it can.
And sine of 15, what can you do there?
You can minus. You'd say no. Wait. Yeah, 45
Copy
minus 30.
We can
Minus
use the.
30.
Okay.
Yeah.
And 1 cos 165.
Mm, mm-mm. Maybe we can say 180 minus something.
Why do you
Yeah,
do that?
no. Mhm.
We can say 165 minus 90, then 70. I think. I don't know.
Tavi saying your mic is a little bit loud. Sorry. Okay. You made a suggestion, Nafisa?
165. Never mind. I don't know what I did. Oh yeah, 165 minus 90 gives you 7. Jesus. 165 minus 90 gives you 75, and then we can use 75 somewhere, like 30 plus 45.
Do you want to use 90? Why don't you do reduction on this?
180 minus
Mm.
165.
Not 180 minus.
Or 180 plus 15.
180 minus 15.
Plus
Yes.
15.
Minus.
Oh, sorry, minus, yeah.
And then if you apply your reduction rules,
Minus
which
cos
quadrant?
15.
Okay, you guys are automatic now. Okay, so and what is cos of 15? Just
Oh, it's not. Oh, it's like
can you
0.97.
but without the
And
calculator?
then, oh, haha. It would be 45
they
minus 30. 45
Yes.
minus 30.
Do you guys see that now?
Mm.
Mm-hmm.
So let's apply the compound angles for this one. What is it going to be?
Cos 30 cos. Oh, wait, the first one. Oh, yeah.
Yeah,
Okay.
cos 30
Cos 30,
Cos 45
minus sin 30.
minus. Mm.
You guys are saying this by heart, I'm assuming.
Yep.
Yes, we
See, you
are.
guys are memorizing the stuff. I told you guys, just memorize it becomes so much easier. Okay, cos 30 is equal to
Root 3 over 2.
cos 45.
Root 2 over 2.
How do you know it's root 2 of
Sin 30 is a half.
If you type in your calculator, gives you. Okay, so if you add 45,
But you also have the
Don't you add
triangle.
so it's 1 root 2.
Yeah, so it's a 1
So
Mm.
over
cos
2.
so why do we say root 2 over 2?
Because the calculator gives that, but when you write it, you write 1 over root 2.
So they're different or the same?
They are the same.
They're the
You're
same.
going to lose mark if you're going to write square root over 2. Because they said don't use a calculator.
But my question to you is, the calculator says this, but you say this. So are they the same?
Isn't it the same?
Yes, they are.
They are the same.
Why are they the
I
same?
think
Because they're both equal to cos 45.
because of the
No,
rationalizing of the
why
denominator.
is this equal to that?
Because we got there by rationalizing the denominator, I think.
So let's break that word down. What do you mean by that? Rationalizing the denominator.
I think it means to multiply by the root
Denominator.
2 over 2. Yeah.
Root 2
I
over
mean
root 2?
root 2.
Do you guys see now?
Yes. Yeah.
Because then it gives you root 2 over root 2 squared, which is 2.
2.
So your calculator doesn't like having a denominator which is irrational.
Mm-hmm.
Your calculator will give you the rationalized form. But I just thought it would be nice for you guys to know that. Okay, so what is sine 30?
A half.
Sine 45?
1 over root
Let's
2.
see.
Okay, when I say root
Yeah.
2 over 2. Okay.
2 over 2.
Okay, and then what is, okay, can we simplify this?
We can take a common factor
Yeah.
out.
Which is, what's our common factor?
Square root over 2.
Okay,
And then we leave towards square root 3 over 2 minus a half. And then you put that on the calculator.
cool, but they don't want a calculator, so it's just going to be
Okay, but
root
they
3
will know
minus
if I'm
1.
using a
No,
calculator.
no.
They must just assume I'm
Exactly.
smart like that.
What's
Yeah.
what's root 2
exactly.
times root 3?
Oh my god.
Your exponent
One.
laws, guys.
Sorry,
Root 2
what? Root,
times root 3.
okay.
Root 6.
Root 6, who said
Root
root 6?
6.
Root
Yeah.
6.
Oh
Thanks, Travis. Minus root 2 over 4. Okay.
Over 4.
Oh,
Yeah.
oh,
Okay. So now
I
let's
thought we
do,
did the same. Never mind.
yeah, so that's the simplest way I think that you can simplify. So let's do sine 45 minus 30.
Oh, sine 45. Okay.
What's the
Sine
rule?
45 cos 30 minus cos 45 sine 30.
Ah, okay, so let's simplify.
Sine 45 is root 2 over 2. Cos 30 is root 3 over 2. I think, yeah, it is. And then
Cos
cos
45?
45 is also root 2 over 2. And sine 30 is a half.
Doesn't that look familiar?
Uh-huh.
Yep.
Yeah, it looks the same like the previous one.
It's not familiar, it's the same. So that's the same answer. So it's so you've got the same answer. Let's do cos 45 minus 30.
Okay. So to be cos 45 cos
But there's
30
a negative
plus,
sign there.
oh, sorry.
So this, yeah, negative cos 45
Cos 30.
Plus sine 45 sine 30.
What's cos 45?
Root 2 over 2
Cos 30?
cos root 3 over 2.
Oh, yo, watch how they all give the same answers.
Then sine 45 is also root 2 over 2 and sine 30 is a half. Okay. I think I know this off by heart now.
But what does the minus do? What does the minus do?
Yeah, you distribute it. I think.
So it's not entirely the same. So because in the past it was that minus, so it's going to be minus root 6 over 4 minus root 2 over 4,
Yeah.
which
Yes.
is, yeah, minus root 2 minus root 6. No, sorry. Minus root 6. Well, it doesn't actually matter. Minus root 2 over 4.
Yeah.
Okay. So do you guys see how you, just by knowing the special angles, you solved all of this? You see?
Mhm.
Tabi Singh, do you have any questions?
Not yet. I understand what you wrote here.
No, I mean any other questions, because that was the last question on the group.
No, I actually came late, so I don't have much question. I just wanted to see how you're gonna do more of trigonometry questions. The same
Do you
as
have
this
another
one.
one? Do you have another one? We have time.
I'm gonna send more trick questions.
But have you done them?
No, but I can do it with you.
Okay,
Live.
okay.
We do it live.
You said that you were going to tell us a story.
Oh yeah.
It's at the end. It's a sad story, Shane.
Oh, okay.
Off camera.
Oh, okay, yeah.
Did you send it?
No, I'm still finding one.
Amara, do you do life sciences?
No, she does eco. That's why we're the only two that does eco.
Yeah, we do ego in business, and then she does something else, and I do something else.
And Rivka also does bio.
Yeah.
Yeah, we're like one of the few girls that do business in ego.
Mm.
How many girls do business?
Because there's a lot of people that does business, but then there's only few girls that does economics. I think
Yeah.
9 of us does economics out of 52 girls.
We
Oh,
don't
okay.
have economics at my school. So
Oh, I love economics.
Me
Economics
too.
Oh, it's my favorite subject.
Is it like maths?
Not
It's not like
really.
maths. It's like
We
no.
just learn about the society and
Is it
how
like more
life
theory?
works.
it's theory and graphs. It's like a mixture.
Oh,
And
okay.
literally
And
understand
like
why
steps.
the increase in price and demand, for example, why
And how the
prices.
economy
Yeah.
works. Oh, it's exciting.
Yeah.
I love it.
Okay,
And then
which
you get
one,
ratios.
Nafisa?
We can do. I don't know.
All
You
of
can
them.
choose. Yeah.
No. No, it's see, the thing is, I want you guys to at least have done to at least have attempted these questions, because then that looks weird, eh?
That does.
How root 2 minus root 6, you see that?
That's why we need to do it with you.
But we just did it.
Okay,
We
but
just
do this one. More practice.
I just showed you root 2 minus root 6.
Over 4.
Yeah, okay.
Mhm.
This one you guys can do because you guys have done reduction,
Yeah.
right?
Mhm.
Okay.
Yes.
This one you can also do because of, okay, let's just do this one, 6.3.
That
what do you-
runs through the triangle.
Okay, so what's the triangle gonna be? Which quadrant is our triangle gonna be in?
Okay, how was
That's
to see?
is cos negative or positive?
Second, negative.
It's negative.
Right. So which quadrant is cos negative?
Second and third.
Okay, and now based on that statement, which quadrants? That's an interesting statement.
Third.
Okay, so which quadrants does this mean?
Yes.
The fourth and the third one. Because it's
Fourth.
going anti-clock or clockwise.
Yes,
The other
because
one.
you can see that it's 90 minus 90 minus 180.
Then
So it's
minus
between
180.
minus. So therefore, which quadrant satisfies both?
Third.
Okay, so you guys see now how you can work out which quadrant. Okay, and you draw your line. Do you bound it to the x-axis or the y-axis?
The x-axis.
Like that?
No.
Or like that?
The other one.
Like that?
Like that.
Or like that?
Like that.
Like that?
No, like the other one.
Somebody.
There you go.
Somebody asked me a question on the tutors. So I'm just thinking maybe I can also do that one. Okay. So right. So what are your sides going to be? So they're saying cos is going to be minus √5/3. So what is that going to be? What's the blue bit?
The adjacent one will be √5.
Minus √5, not right. And then the hypotenuse is going to be.
Hypotenuse.
What's this side going to be?
Hypotenuse is
You can work it out.
I'll work it out. Why do I feel like we've done this before?
Okay, I got 2.3, but obviously it will be negative because
√5 squared is 5. What is it going to be?
oh no, I forgot to square it. Sorry. Okay. It's 5.
No, it's going to be -2.
Yeah.
You guys agree?
Mm-hmm.
Okay. And they say that 2 tan beta equals, so that there's another thing that we have to draw now because it's a different angle. So we can draw a different one, right? Different one.
And this one is between 180 and 360.
So we're going to rewrite tan beta as
Negative √3
negative
over
3/2.
So which quadrants is tan negative?
Second and fourth.
Right. And then what do they say B beta is?
Between
between
180 and
180 and
360. So the third
So
and
it
the
will be the
The fourth quadrant.
You guys see how easy it is? Okay. So let us do that. And we can do that. No, let's change the color. Okay. So what do we know? Tan beta. So who's going to fill it in for me?
opposite over adjacent.
Yeah, so it will be negative √3 and the adjacent will be 2.
And with the hypotenuse?
We have to find it. We have to
So I
calculate
want you guys
the
to find it.
hypotenuse side.
What do you guys get?
I got √7.
√7, right?
√7.
Because 2 squared is 4, √3 squared is 3, so 4 plus 3 is 7, so it's √7. So, okay, so we've constructed our triangles, right? Okay. So now they want cos squared plus sine squared. So what's cos of A? Don't you think, can't we just find cos of A and square it?
Mm-hmm.
You guys agree? And then
Yep.
can't we find sine of B and square that?
Yeah.
So do you guys see it's not because they want us to find cos squared plus sine squared. So what's cos of A?
Cos of A is
Square root 5 over 3. Negative square root 5 over 3.
Squared, it's going to be what's minus root 5 over 3 squared?
3 over 9.
5 over 9.
Wait, what's 5?
Because it's negative root 5 squared. Okay, and then sine B squared, what's sine of B going to be?
Negative root 3 over root 7
Squared.
squared. Yeah.
Negative 3 over 7.
Not negative.
3
3
over 7.
Okay. And the lowest common denominator of 9 and 7 is 63.
63.
63.
Oh,
62 over 63.
yeah, it's quite a nice. Okay. Okay, happy guys?
Yep.
So do you see, are we doing any new maths here?
No.
Are we inventing new maths here? A lot of people tell me, Elias, like, yo, in that maths exam, I invented stuff, man. I invented new maths. Like in a bad way, in the sense that they didn't know what to do. But what I'm trying to show you is that all these questions, it's just the same concepts, but we're just applying them in different contexts. So it's the same concept. Okay. 6.4, identity.
Oh God. Okay. Yeah.
Yes, that's the best part of Trigs. The only nice.
So you can't prove it. So,
So which side do you want to work with first? Maybe the left-hand side, right? It's more
The
complicated.
left-hand
Left-hand
side.
side.
Yes.
Okay, sure. What can we do? What do you guys think? Sin x times cos x, do you think we can change that?
can we do that
Yeah.
half?
Half. So then we'll get half into 2 sin x cos x. And then we can change that into a
That identity.
Okay,
Can we
maybe
also
should
change
we not
1
minus
into
sine
I
squared?
mean,
Yeah, 1 minus sine squared into
Cos squared the
cos
x.
squared. So let's write that as sine x cos x over 2
Cos
Cos x. Cos square x.
mm-hmm.
I don't like how
cos
that looks. Oh.
Yeah. Then sine x over 2 cos x. Oh, okay. Yeah, this easy.
what's sine x over cos x?
10.
10.
10.
Okay.
I love this.
Hence hence. Determine the general solution.
So we just take this answer here
Yes.
And make it
And then
equal
make
to
it
a
equal to
half. And
half.
find the general solution of that. Yeah.
Yeah, there we go. So what's half tan x? So
Mhm.
what do we do now?
Can we divide by a half?
Don't ask, can you just tell me? Because the thing is, you can't ask in the exam. You can't be. Can I do that? Can I do that? Let me message. Let me message Tutonic in the
I
exam.
actually
You
asked
can't. You
myself
can't.
Yo,
this while I'm
imagine we
doing
could
this.
do that. Yo,
Okay, so half tan x equals.
1. No,
So
tan
tan.
x equals
Tan x is
1.
equal to 1 because you can't have anything before the ratio.
Yeah.
And then the reference angle is equal to 45.
And then you say
Tan is positive in the first and the third. So 45 plus k.
Plus 180.
No.
Into 180.
Yeah.
K is an element of Z.
Now you don't have to worry about the third quadrant. Why do we say? Why don't we have to worry about the third quadrant?
Because it's the period of tan is 180 and then the third quadrant is more than 180. That's all.
No, not necessarily, because if do you agree? You just said now 45 plus 180k.
Mm-hmm.
So what if you make k1? What does that mean?
It's going to be 180. 45
Plus.
plus 180.
But isn't 180 plus theta the third quadrant?
Yeah.
So therefore there's no need. So this formula that you've created includes the third quadrant. So with tan you only need one of them.
But say in our exams or a test, whatever, we have something similar, right? And we don't actually see the pattern that you just showed us. And if we just write the third one, I mean, they can check the first one, right? So can we just,
The third one will still be correct, but it's not necessary.
Oh, okay. Okay.
Because your answer includes the third
Yeah.
quadrant. But this
Yeah.
only works with 10. Only works with 10. There was another question that somebody asked. Why does this question look familiar? Maybe we can just quickly zoom through it. Zoom. You guys get it? No, you don't get it.
That was funny. We did this question, didn't we?
Did we do this question? And I can tell just to wash the bank.
Very familiar.
This does look very familiar though.
But
Why
it
does it look
looks
familiar?
horrible also.
But we did it though.
no, I don't think so.
No.
Yes, I think
Did we do it?
there
It's a
is a
hyperbola. It's a hyperbola question.
yeah.
Yeah.
No.
I don't think so.
No, we didn't. Maybe we did something similar, but
Are you sure you didn't do it?
Yeah, we did. Because we do have we did do similar questions, but I don't think
Why is it not going? Okay, so let's just do it. Okay. The sketch below shows the graph of, it's a log graph. It's a log graph. Log 5x. Okay, so now you guys can help with this one. So y equals log 5x. Okay. And g of x is 2 over x minus 1 plus 1. So what do you guys know about this hyperbola? So if I give you the equation 2 over x minus 1 plus 1, what do you know about the hyperbola?
the
The
asymptote.
is plus 1.
So how is this graph shifted from the graph 2 over x?
It was shifted vertically 1 up.
Up by 1 into the right by 1.
Right. So do you guys agree that the asymptote's going to be x equals 1
And y equals 2.
And y is equal to 1.
Okay, and you guys know there's a concept in hyperbola if you want to revise. T and U are x-intercepts there and there,
Mm.
but they have different graphs. So the U is for
Mhm.
the U is for the log and T is for the
Log
hyperbola.
1.
The line y equals x intersects the asymptote. Wow, okay. So therefore that R is 1, 1. Do you guys agree? If it intersects the asymptote, but we said the line of the asymptote is x equals 1 and y equals 1. So therefore the intersection is just going to have x 1 and y equals 1.
Yep.
Okay. Write down the okay, no, it's not. Okay. The coordinates of u. What's u?
The x and the x-intercept of the log graph.
How do you find the x-intercept of the log graph?
Mm.
Make
How
y
did you
equals
find it?
0.
Make y 0. So naught equals log 5. So how do you solve this?
Oh, how do we solve that?
Can't.
That's because I wrote it incorrectly. Sorry. It's naught equals, yeah.
Isn't the base 5 and no, so much.
X equals to 5 exponent 0.
5 to the power of naught equals x. So what is x?
X is
1.
1.
And doesn't that make sense? Because isn't 1 on the asymptote line?
Yeah.
Right?
It
Isn't
makes
u?
sense.
Okay. So there's 2 ways that you could prove it. And then number 3 says, number 2, the equations of the asymptote. Okay, we've shown that already, right? The coordinates of t. What's t?
It's the x-intercept of the hyperbola.
Yeah. So how do you find the x-intercept of the hyperbola? You make y naught.
Make y equal to 0.
2 over x minus 1 plus 1. You multiply by x minus
Take the
1.
1
So,
over.
yeah, well, I'm just okay. So 2 plus x minus 1. So x equals minus 1.
Yeah.
Which is also what she got. Okay. So we answering. Write down the equation of h, the reflection of f in the line y equals x.
Oh, okay. Yeah. So it will be 5x. 5 to the
5
power of
to the
x, sorry.
Yeah, you just
Yep.
swap the x and the y. Right?
x equals log y. So it's 5 to the x equals y. What's the domain of 5 to the x?
X is the element of real.
Yes.
Why?
Somebody else y? Oh,
I think Amaro asked why.
No, I said why. Sorry, never mind. No, I said the little one.
you mean y is in the letter y, sorry.
Yeah,
Okay.
sorry.
Right. Now write down the equations of the asymptote of hx minus 3. So what does hx minus 3 mean to you guys?
There was a shift.
Now, what type of shift?
3 units to the right.
Horizontal.
Horizontal shift to the right. Well done. So if h of x equals log x5, what is h of x plus 3, the equation?
No, I think h of x was 5x, isn't? Because it was the inverse.
Yes, sorry. So h of x is 5 to the power of x.
Yeah.
So okay, so what's the new equation going to be?
5 to the power
E to
of
the power x. No? Oh.
x minus 3.
5 to the x minus 3.
Mm-hmm.
Because you just substitute that for whatever x is. Doesn't this mean, guys, that you're subbing this in place of x?
Yeah.
Yes.
So that's
Yes.
what it means. You just, wherever x is, you're putting x minus 3. The coordinates of v. Where's v?
With it's point of intersection, so you make them equal to each other.
B is the intersection.
Of what? What intersection?
Straight line.
Of the
And
two graphs.
Of the line y is
The
equal to x and the hyperbola.
straight line.
So if the hyperbola is y equals 2 over x minus 1 plus 1,
Mm.
what can we do now?
So you make it
And-
equal to x because that line is
So-
y
the
is equal
y
to x.
cancels, right?
So the y equals x, so you can replace y with x.
Mm-hmm.
Second times by
Now-
x minus 1,
So what's x times x minus 1?
x
It's that.
squared minus x.
2x minus 1. Yeah. So that
So
will be
it's
x
x.
squared minus x2 plus x minus 1. Then you just factorize it. I mean, take everything to one side and factorize it. So
It's x squared
what is
minus
that?
2x. Is it x squared minus 2x
Yeah.
minus 1 plus 1?
What?
And you can
Is it, so it's x squared
Uh,
minus x equals
Yes.
2 plus, so 1 plus x.
X minus 1. Yeah, this was wondering where
Yeah.
okay, yeah.
So it's x squared minus 2x minus 1 equals 0.
Oh yeah, got it. Okay.
That
Now
can't
we
be factorized.
factorize. Oh, okay.
I don't think it can be factorized.
It gives you
one.
a decimal answer. So I got 2,4. And
Why do you get 2 answers?
And negative
Because-
0
it's a
point.
parabola.
They intersected 2 points.
I mean, it's a trinomial.
No,
Okay.
because they
It's two-
intersected
yeah.
2 points.
It's a
Yeah,
function.
They
there's an
intersect.
intersection by the O there, and then there's an intersection by V. So you are supposed to get 2 answers. But then you take the positive one because it's in the first quadrant.
So do you guys understand the equation now? So the equation doesn't know which one you want.
Mm.
The equation doesn't know whether you want this one or this one. So you have to use your knowledge to say, okay, it's going to be the positive one. Right, you guys agree?
Yes.
Mhm.
But they want the coordinates of V. So how do you find the coordinates of V? You've got the
You
Y.
get- Yeah.
So we got
You
the
get the
x, so
which is
now we
2
substitute it back into this equation to get y.
Mhm. Do you need to substitute it back?
Yes.
Isn't Y equals X?
Oh, so it's 2,4 and 2,4.
You see, now the thing is, you guys could have substituted it back, but then you would have been like, why am I getting the same answer? So do you guys understand why it's the same answer? Because the lies on the line.
Y is equal to
Y
X.
is equal to that.
Okay.
Oh.
So now numbers 4.7. That was 4 marks. Wow, 4 marks for that question. Determine the coordinates of T prime. The point which is symmetrical to T about the point R. So where's T?
Here on the x-intercept of the hyperbola.
So there's T and there's R. And they want you to find the point which is symmetrical. What do you guys think?
So it's on the hyperbola.
You can just swap the coordinates, right?
I
Is
don't
this not?
think so.
Isn't this the midpoint?
Yes.
Oh, okay.
Do you guys agree it would be the
So
midpoint if you were to draw a line from the there to the point of reflection? It will be the midpoint. So can't
yes,
you use midpoint formula because you have the 2 points?
Wait,
You got the mid
what are they
How do
asking
you
you to
know it
work
is the
out?
midpoint?
because you're reflecting
because
it.
it's symmetrical also.
Because you're reflecting it about the point R. So if you reflect this about point R, then it's just going to be the same distance. So if you just draw a line, then that's going to be the midpoint. Do you guys see that?
Yeah, so do you just change the sign? So it's 1.
No, you use midpoint formula. You use the midpoint formula.
Yeah.
Oh.
So it will
So
be you'll say x plus -1 divided by 2 is equal to 1. 0 plus y divided by 2 is equal to 1. Then you calculate it.
So you've got your 2x values, which is -1 plus x over 2 equals the midpoint of which is 1. Therefore, x is 3.
Yeah, it is.
And then for the y's, it's 0 plus y
Plus
over
y.
2 equals 1.
Equal to
Therefore, y equals,
y
2.
equal to 2.
and there's your
Yeah.
coordinates of t prime. So do you guys,
Now we are done.
did we invent new maths?
No, but because of I didn't know how to approach this 4.7. So
Did you try
this
this
is a
question
new
before?
way.
But now,
Yes, I did this question. I
but do
did
you
this
see
question
now?
before, but when I look at the memo I got, it was 3:2. 3:2, but I didn't know how they got it.
Yes. So this is why I always say people don't worry, don't. The memo is misleading because it doesn't tell you how to think. That's the difference. Tutonic, the memo tells you what to do. Tutonic tells you how to think, and by thinking, it tells you how to get there. That's why many students memorize the memo, and that's very problematic. So I avoid the memo as much as possible because there are mistakes in the memo sometimes, and then you just confuse yourself. But the main thing is, Tavi saying, now you've learned a skill. Do you guys see that you've learned a skill now? You've learned a skill that if they ever ask you to reflect
Yes, I
something,
did.
you can say, okay, that must be the midpoint. So therefore, you can work out. Okay.
So mostly reflection, you can use the midpoint formula to get the other coordinates,
it's one
depending on the question.
Yeah. Well, that's only because they gave us these points, right?
Yes.
The other way
So
is
if like the way to say that we find the coordinates of R, and then we were given those 2 points, which is prime of T and also T, we were also going to use the distance. I mean, sorry, the midpoint formula to get R.
Just say it again.
Let's say if we were given T and also the prime T that we were looking for, and they said we must find the coordinates of R. We were still going to use the midpoint formula, or it will just depend on the question, on what we were asked to find.
Yeah, so some other times you might some other times you may not need to use midpoint, but all I'm trying to say to you is that if you can add this to your brain, like, it's like your brain has got a toolbox. So if you add this to your brain, then it's almost like in the future, this is a possibility in your brain for these types of questions.
Okay.
That's all I'm saying. So that, because if you've never
Okay, so-
Did you freeze?
Mm.
Okay.
Oh, my network is giving me problems.
I don't think it's you, because we can't hear him either.
I'm still here, but the thing is, I
Oh.
think laptop is actually well, if you finish basically, but
No,
yeah.
no, you need to give the story. I mean, tell the story.
We
We've been
took
waiting.
time.
Okay, wait. Okay, let me just fix this now. Let me just quit Zoom. Please stop. I'm not gonna quit. There we go. Let me just
Stop the live session.
no, I'm gonna stop the YouTube.
Yes.